Hello, everyone. Today is a great pleasure to meet you here in the Micro Durability Conference. And in this special section on recycling materials, I would like to share with you my study on municipal solid waste incineration bottom mesh. And the topic here is the potential application of MSWI bottom mesh as substitute material in Poland cement concrete. And here are the content I would like to talk about today. First, the background of this study. Here we see from 1995 up to 2019. In Europe, where each person generates about 500 kilograms of municipal waste every year. And we see in more recent years, more waste materials are being recycled and incinerated. And the less amount of the waste are directly landfilled. However, there are still about 25% of incineration waste materials to be dealt with. And here is the so-called waste to energy process, which is the energy recovery of generating energy in the form of electricity or heat through the incineration process. And by doing so, we have mainly two kind of byproducts, namely the fly ash and the bottom ash, and they are regarded as zero cost raw material. And their application could be regarded as both the conservation of resources and the elimination of waste. And today, here we focus on the application of bottom mesh. And according to the literature, here are several potential applications regarding the bottom mesh. First, they could be used as the aggregates in the pavement construction, and they could also be used as substitute material in concrete, as cement, filler, or aggregate replacement. However, there are several main problems. First one is their highly porous microstructure, and then the lower activity due to the quartz and the unburnt organics. And the third one, the volume stability issues due to the metallic aluminum content in bottom mesh. They will generate hydrogen bubbles due to the reaction between aluminum with the alkaline environment in Poland cement. And so they will cause the expansion in hardened paste. Finally, the leaching issues related to the heavy metals and harmful salts. And in this study, the bottom mesh is provided by a Netherlands company, and they have performed a washing process before delivery, and we see there are still a lot of impurities, and the composition is still very complex. And the morphology detected by SEM, here we see a very high porosity microstructure, which will result in the low strength of particles. And on the other hand, the pores will act as water reservoirs. They will absorb extra water in the fresh cement paste. So pretreatment should be done before they could be applied as a substitute material in the Poland cement. Regarding the metallic aluminum content, first method is the mechanical treatment, which is a low-speed grinding process for short well, so that the metallic aluminum could be ground into place and then sieved out. And also the chemical treatment, but the bottom mesh samples will be immersed in the alkaline solution so that the metallic aluminums could be directly dissolved. And regarding the lower activity and unburnt organics, uh, the thermal treatment is possible by heating up to 1000 degrees Celsius to generate some reactive phases, and also the unburnt organics could be removed as well. So in this study, we have three types of treated bottom mesh samples. First, the MBA by a physical treatment combined of grinding and sieving process, and also the chemically treated bottom mesh with 0.1 molar sodium hydroxide solution for 15 days at a solid to liquid ratio of 0.2. And the treated bottom mesh was then washed with running water and oven dried before further grinding process. And finally, we found that the MBA is not reactive enough, so we further performed the thermal treatment on MBA at 1000 degrees and in a ventilated furnace for 2 hours and then cooled down to room temperature. The characterization of treated bottom mesh samples, the crystalline phases by XRD. Here we found out that there's no significant difference between a bottom mesh and the MBA. The peaks in CBA samples are even more narrow and lower, which indicates that part of the amorphous phases were dissolved during the chemical treatment. And after the thermal treatment, we found there are more phases. Well, the peaks corresponding to the calcite are vanished, which could be attributed to the high temperature process. The chemical composition of treated bottom mesh by XRF study. Here we see in all bottom mesh samples, the calcium oxide content is much lower than Poland cement, while the silicate oxide is much higher in bottom mesh, which is corresponding to the quartz peaks detected by XRD. And here the metallic aluminum content is determined by the measuring the hydrogen gas generated through the alkaline dissolution with the setup illustrated here. And we found out that thermal treatment further reduced the metallic aluminum content in MBA, probably due to the high temperature oxidation process. And the further investigation on paste level to check the effect of different treatment. First, the compressive strength of hardened paste at 7 and 28 days with a fixed replacement ratio at 10%. Here we select M300, which is a micro quartz sand with no reactivity. They are used as a filler substitute in Poland cement. Among all of the substitute materials, we found out the highest compressed strength is with 10% of MBA, higher than MBA, and followed by M300 and CBA with the lowest compressive strength. Also, the estimation of amount of hydration products at 28 days according to the TGA measurement. Here we found out the amount of pollen diet and the non-evaporable water amount is in agreement with the compressive strength study. So here we come to the conclusions. First, both the chemical and the mechanical treatments are effective to remove the metallic aluminum content. They reduced the metallic aluminum content by 95 and 84% respectively. And some amorphous phases were dissolved during the chemical treatment. And then the thermal treatment further removed the metallic aluminum content and also results in more amorphous phases and higher strength. in the hardened paste. However, this high temperature process might be energy consuming. Regarding the performance of substitute materials, TBA is better than MBA, then the micro sand and the chemical treated bulk mesh is the worst. And finally, MBA could be regarded as a proper filler substitute material in OPC concrete. So that's the end of my presentation. Thank you very much.